One of the great wonders and puzzles of physics is friction. It's the reason that wheels stop turning after a while. It's the reason that we lose energy into heat. And it's also the reason that we lose electricity into heating up wires. What is fascinating is that there are systems called superconductors where the resistance is absolutely zero. Our graduate student is performing Faraday's 1831 experiment. He's bringing a bar magnet close to a conducting loop. As the magnetic field in the loop increases, there is a current flowing in the loop. That's the electromagnetic induction that Faraday discovered. That current does not stay at the same value. It diminishes over a short amount of time and disappears once the magnet stops moving. This comes from the fact that there is friction in the copper wire. Physicists and technologists have been investigating friction for a long time. Then comes a new player, which is called superconducting materials. Superconducting materials have zero friction. They generate no heat when current is passed through them. In fact, a current can pass through a superconductor and keep going on forever and ever in a ring without generating any heat because it has zero resistivity or zero friction. Why does it have zero resistivity? Well, that question can only be answered within the realm of quantum mechanics. This fascinating demonstration of the same Faraday effect, but now with a superconductor instead of a normal copper wire. So we have a magnet which we bring close to a superconducting material called yttrium barium copper oxide. This material has been found only 2 decades ago to be a superconductor at relatively high temperatures, so we can get this material to superconduct by just pouring over it liquid nitrogen. Once the nitrogen cools the superconducting down, the superconducting material passes current with zero friction. Now, as we approach the superconducting system with a magnet, currents start to flow inside the superconductor, same way as they flowed in the Faraday effect, and they generate an opposite magnetic field that repels the magnet that we bring close and actually lets it float. What is amazing about this experiment, this magnet is floating in the air because of persistent currents that we generated in the superconductor, and because there's no friction, they keep flowing forever. High-temperature superconductivity is yet an enigma and a mystery that we all investigate. There are two challenges here. One is to find a higher temperature superconductor, another to find superconductors which have a bit better material properties that could be made wires out of them. Wires could conduct enormous amount of electricity with zero costs of heating and dissipation between faraway power plants and consumers. Other applications would be having very strong magnets, and those strong magnets can help levitate equipment, levitate cars, trains. Higher temperature superconductors will be a great technological revolution in the energy industry.